All right.
I might dissemble.
Ladies and gentlemen, and everyone else. Really, did I really just lose my notes?
That's why Gary Ross used those.
I know. Clearly.
It's all modern technology.
As my grandmother would say, if it's a machine, give it a whack.
It's Gary Ross, a legend in his own mind.
I had a perfectly lovely introduction prepared here, so I am going to insist on retrieving it.
Think Fred Astaire.
A piece of paper.
Yeah. Well, you know, trees have lives too. All right. This evening we are going to hear the presentation Occultations, including the Great North American Fiasco of 2014. I still prefer the original title, Occultations Culminating in the Great Regulus Fiasco of 2014. March of 2014 saw a minor disaster for asteroid-stellar observing, and that is what we're working up to tonight. This is going to be Gary's penultimate presentation before he gives up the life of the mind yet again. That will probably last for about as long as it did last time. So, the speaker's biography. Our presenter tonight observed his first lunar occultation during the second Eisenhower administration. In the old country, he would be deemed a man of no importance. He first addressed the Warren Astronomical Society in 1962, our second year of existence. In later years, he maintained he would never join, heavily involved in the Grand Rapids Association as he was, but resolve weakened during a snack break from after invitation by Brian, the Candyman Klaus. He has been recently recognized as the least popular host of the roving discussion group. Ladies and gentlemen, I give to you the second greatest observer in Michigan, Gary Michael Ross.
Proud tonight to be the people's spokesman. I'm just Jacques Bonhomme, right? Ordinary fellow. By the way, I failed to mention, I have a deep prejudice against laptops and eye dorks. I have stopped 2 lectures with an admonition, but I kept it clean. We, as amateur astronomers, we first basically serve ourselves, spiritually, intellectually. But I have here something, an essay, from a 1999 issue of Science, over the pen of Forrest M. Mims III.
Ah, my good old friend.
You know the man?
I do.
He does.
The Experimenter's Handbook author.
Oh, all right. An editorial in a leading science journal once proclaimed an end to amateur science. Quote, modern science can no longer be done by gifted amateurs with a magnifying glass, copper wires, and jars filled with alcohol. I grinned as I read these words, for then as now there's a 10-power magnifier in my pocket, spools of copper wire on my workbench, and a nearby jar of methanol for cleaning the ultraviolet filters in my homemade solar, ultraviolet, and ozone spectroradiometers. And apparently, according to our comrade here, this man is a dean of amateur science in some regard, an 18th century gentleman.
Effectively, he's also on Twitter.
Oh, we'll overlook it. Right. I call it fritter.
Fritters.
For amateurs, do science because it's what they love to do. Without remuneration or reward, enthusiastic amateurs survey birds, tag butterflies, measure sunlight, and study transient solar eclipse phenomena. Others count sunspots, discover comets, monitor variable stars, and invent instruments. And Jerry Persha of my town, as an amateur, with a lousy bachelor's in physics, grew rich and changed the nature of variable star observing and atmospheric monitoring in a factory that he built, as did essentially Henry Ford, although on a somewhat smaller scale. Jerry Persha is one of the premier amateurs in the world because of his inventions, based upon intellectual curiosity and technical acumen and a business sense, and they all came together in one man. An amateur astronomer, nota bene. Many amateurs have contributed observations and data that have been incorporated into papers and books. Some are accepted as colleagues by their professional counterparts. They present their findings at conferences and publish papers in peer-reviewed journals. For each of these, hundreds more devote their spare time to making observations, measurements, sketches, photographs, and reports without receiving direct recognition. And then a couple of columns over, astronomy has traditionally been among the most fertile fields for serious amateurs. As we enter the next millennium, remember this is written in 1999, the future of amateur science has never looked better. Amateurs built some of the first home computers. Today, many of us own systems that far outclass what was available to our professional colleagues only a few years ago. It no longer matters that I can't do a nonlinear regression with a calculator, because economical software does it automatically, and an inexpensive printer then produces plots as crisp as any published in Science. Repeat, this is Forrest H. Mims III. Sounds like a 17th century gentleman, or if you prefer the Renaissance Italian, uomo universale. I'll translate it at the bar. This is not a commercial for IOTA, International Occultation Timing Association. However, this organization is one amongst the first of amateur science organizations, and it is international. They have workers in Australasia and Europe and all across North America. And to get on their website, is a real lesson in the status of advanced amateur astronomy today, and what these citizen scientists can and are capable of doing. Now, I am not a member and never have been a member of IOTA. I know nothing of the resume of the leadership of the organization, or what the membership are like as individuals or collectively. All I know is that they are highly dedicated to the observation and the recording and the reduction of observations for occultations. They are in the same rank as the American Association of Variable Star Observers. I'm not sure how many of them there are. But this is an organization representing amateur science at its best. And they are bulldogs when it comes to getting data. It's amazing. The first time I heard a talk, it was a paper given at the Astronomical League in the 1960s, of all these hotspur lunar occultation observers who were going to some small town in New England and converging from all directions at an inconvenient hour and at great distance. And so over 50 years ago, I could see the dedication of these occultation observers. And my admiration for these people has only deepened in recent years as I've perused their website, which is essentially an encyclopedia of the subject in its own right. And I would recommend it. not to get necessarily involved in occultation observations, but just to see what others are doing. It's bloody impressive. So, what is an occultation? Occultation means to cover. Now, the occultations that we are most familiar with and are the easiest to observe are occultations by the moon of some other object. The stellar occultations are far and away, by a couple of orders of magnitude, the most common. I followed the old ways, analog. Look upon it and tremble. Now, I am trying unsuccessfully to raise the time signals WWV. When I was a laddie, it was from the National Bureau of Standards. Now what is the name of the organization?
NIST.
Sorry?
NIST.
NIST.
National Institute of Science and Technology.
Technology. Boulder, Colorado. This is WWV 10. This is WWV 15. And 5 has never worked for me. I cannot explain why nothing is coming through. Maybe it's the building.
Fluorescent lights.
Yeah. No, it's a building.
Building, all right.
Or if you use digital, you probably.
I don't need no stinking digital.
I just lit a fire. It just was too big an opening.
Occultation, for the ear and stopwatch types, these are the two channels one uses in North America. I have used both. Parentheses. I am not passing myself off as an expert in, or for that matter, particularly knowledgeable about occultations. It is not exactly my run of country, but I have done it. In the old days, at the Wien Observatory in 1970s, it was for Herstmonceux Castle over in Great Britain, the British. Then the World Clearinghouse shifted to the Hydrographic Institute in Tokyo, and the observations were done by time signals at the Wien Observatory and stopwatch. In other words, visual, auditory, and so. The Japanese, well, both the British and the Japanese were interesting to work with, sending off observations, sending love notes, theater reviews of Japanese films that I'd seen, in brief, of course. They tolerated it well. But the Japanese gave up the work, many years ago now. And IOTA, for at least North America, is the place to send observations. I haven't, frankly, done very much at all since 1990, and that was with the Japanese. I've submitted a few observations to IOTA, very few. But in those years, I've moved on to other interests. The first occultation I observed was in 1960 with 6-inch homemade Newtonian, occultation of Aldebaran. And it was spectacular. And I think now that occultations of stars by the moon, I'm thinking, now I've never read this anywhere, but I can think it through. that astronomers in the early years of the telescope era might have thought, when we watch the moon cover a star, we'll be able to measure how big the star is. Because we all know the brighter the star, the closest, right? Well, at least that's intuitively true. In fact, it is balderdash, however. So I imagine the first sustained observation of a stellar occultation by the moon, and the astronomer is there. He may or may not have had a clock, but he's watching. You know, he could time things, 1 hippopotamus, 2 hippopotamus, what, you know. And the moon approaches the star, some big bright star, all right, Antares, Regulus, Aldebaran, a star that's very close, right? And it goes, boop, and the astronomer says, I don't know how long that took. It was instantaneous. So the star is either really far away or it is really small. I wish I had a better timepiece, some way to measure this. And that, to my thinking, and I repeat, I found this nowhere in any, it's not that I've searched for this, but it had to happen at some point where an enterprising astronomer made a sustained attempt, say in the 17th century, maybe early 18th, to observe occultations, and was disappointed because it could learn nothing. It was a grand sight, but it could not measure the diameter of a star. Well, that's because even the bright stars are pretty small. There are two kinds of stellar occultations. There's the basically full-on, where the star will be intercepted by a limb of the moon. Or there are the famous Gray's observations. IOTA makes a special effort to observe grazes. This book, The Observer's Handbook of the Royal Astronomical Society of Canada, the Book of All Knowledge, which is why I am so smart. I have this book. I sleep with it under my pillow like Charlemagne. Right?
Specifically the 2014 edition?
No, I've evolved to the 2016 edition. Right? I like to take my time, savor it like fine wines. Or as the rabbi says in Fiddler on the Roof, if you want to give me bad news, tell me about the flood. This is an excellent source for occultation predictions. If outside of, obviously, the IOTA website or publications. But Gray's occultations are of a special interest because from these events can be generated, and have been generated for a long time, lunar profiles. And observations of occultations in general are valuable for astrometry, stellar positions. Now those stars do wander, you know, and lunar motions. No, it's not like clockwork. There are variations in lunar motions. And to study a great number of occultations of the full-on variety, or even of grazes, can lend itself to changes in lunar motion. If one predicts a graze at a certain geographic location, and it is not a graze, it's a miss, or it is an occultation, a full occultation, then something is amiss. Now, I'm not saying that anyone has cocked up, but it is valuable knowledge in terms of what the moon is doing in its orbit and what the stars are doing on the celestial sphere. The Gray's occultations have to be observed with great care in terms of one's geographic location. That a few tens of meters in some cases can make a difference. Now, in the old days, for at least Americans, one would have to get out the USGS quadrangles, the 7.5-minute quadrangles, to establish one's position by interpolation and by careful measurement of the quad sheet, as we used to call them. Today, all you people go, and it gives you what? You know, practically one cow plop away from your true, location. Right? It's easier now, I will admit. I have never done it, but I am told it is efficacious. Right? I leave it to others. So, observing a graze requires a lot of organization and attention to detail that the organized observers, if they can get a team together, will set up at various stations perpendicular to the eclipse path. Some will see a graze, a few, maybe one. Some will see a clean miss, and others will see a full event. The last time I tried to observe a graze occultation was in Ionia County around 1991, and we had clouds coming in and out. Oh, it was lousy. I saw nothing. I saw a full miss. We only had 3 of us, and with the weather, and I was traumatized, and I've never attempted it since. I gave myself to drink, which is true, because having failed at this, we repaired to this kind of dirty, mean bar in downtown Saranac, right? And just entertained each other with lies and recriminations. But it made it almost worth it, right? I mean, if you just go home after some fiasco like this, you wonder what the hell you're doing with your life. So, you got to find a saloon, right? Get up that old whiskey courage to try it again, which I never did. because in the 1990s, I matured, right? I've been there, done it, whatever Americanism one wants. Stars are the vast, vast majority of the occultation events. However, the moon can also occult a planet, and these occultations can be beautiful in the extreme. And at one time in the history of astronomy, they were also valuable for measuring the precise location of that planet, or even one could say that if it were an emergence from the dark limb, maybe on that planet seeing detail that would be difficult otherwise to study. And in this sense, I'm going back possibly to the latter part of the 17th century. Today, occultations of planets are not that important, but they are certainly striking events. The first occultation of a planet by the moon was recorded, was thought to have been, I don't know whether he was an Arab or a Persian, in the medieval times. He recorded it that the moon covered Venus. It was a morning event.
Who was it?
Now, I am not going to say that nobody in human history before this had ever seen an occultation of a planet. It's just that who's going to write it down in a society that's 97% illiterate or more, or records are lost? It does surprise me a little, and I'm not a sinologist, that the Far Easterners, those diligent Koreans and the Chinese, never observed such a thing. I find that impossible to believe. It could be, and I find it impossible to believe that they didn't think it was important if they did. records are lost, or maybe they're in some archive somewhere waiting to be translated from, God knows what dialect. Perhaps these observations someday will be unearthed. I don't know, but I find that suspicious. However, this diligent astronomer in Southwest Asia was wrong. In the 19th century, was he British or American? Did the calculations for that day and that hour and found, and of course the location on Earth. That's important too. Even though this is Venus' sun, if we're talking about half a continent away, that makes a difference. No, he did not observe an occultation of Venus. What he saw was an pulse, approximately 1.5 arc minutes away from the moon. But the moon was so bright that he could not see the planet that closely. The moon roughly is 30 minutes in diameter, so he's the planet's 1.5 minutes away from the limb, and he couldn't make it out, which doesn't surprise me, because I forget what the phase of the moon was. I mean, it can be bright even if it's in crescent phase. And speaking with a certain sad experience, it also depends on the quality of his vision. And that can be dodgy. I'm sure many of you understand that, right? Eyeglasses were invented by the Venetians when? In the 13th century, right? So most of us, when we get past 30, have a problem. So his vision may have been a factor in this. Don't know. Then we come to the really exotic things, in which the planet is the occulting body. My first experience with this kind of event, the planet as an occulting body, was in the spring of 1962, when all the usual suspects with our telescopes went out to our family cottage. It was somewhat after Easter, 1962, that Saturn was going to occult a star. The sky that night was caca. It was a total washout. But this does happen from time to time. And when a planet moves through the galaxy, the plane of the galaxy, which, by the way, did not describe that morning in 1962, then the chances go way up. I'm sure that this has been calculated by the IOTA people or the British Astronomical Association or the Japanese years and years ago. I don't know it because I'm not really in the game. But that was quite disappointing because this wasn't just a little occultation. The planet was Saturn, given its the ring orientation. See, the rings went edge-on in 1966. So in 1962, they were still open. And that was a good, dead nuts event. It would have been fascinating to watch, even in our small telescopes, talking about 6-inch, 4 1/4-inch telescopes. But it was awful that night. The planet can occult a star, fine. Now, but planets come in all different species, genera, and families. There are really big planets like Saturn. And then there are teensy-weensy planets, of which, well, Ceres would be a great, huge behemoth by comparison. In 1959, July of 1959, Venus occulted Regulus. Now, I didn't get in on that action. My brain was too primitive in July of 1959. But I got out, Kel, I think the archaeological French is Kel, the original document. This is like the Torah, man. Sky and telescope, right? Look at this. Not on DVD.
Which is available from the club's library for free.
Not online. No, no. A book. A book. Too big to fit under my pillow, right?
That could be your pillow.
Look at this. Open it. Pictures, writing. Many of you, I'm told, can read. Look, look. I have done my best to find, this is Sky and Telescope. This, you know, with all due respect to what the Europeans and Japanese are doing, and the Soviets, right? This is the world's premier astronomy magazine, the hybrid of the amateur and the professional. I have looked and looked and looked, and I'll be damned. 7th of July, 1959. The only report that Sky and Telescope carried was this teensy-weensy thing, significantly enough, by their Occultations supplement. Sees the maps with all the circles of the United States and Canada. Those are the stations. And look, data. Not on a website, on a page. Right? When your websites go to slush because it all gets demagnetized, Sky and Telescope will still rule, and we can rebuild human knowledge from these books while all your eye dorks turn into slush, right?
Until the fire.
These are in multiple editions, right? Multiple editions. There's not only a book like this in the Wien Observatory, I'm told there might even be a book like this at the University of California someplace, right? But all your eye dorks are going to just go to slush, right? And people will forget even how to think, insofar as they're any good at it anyway. So, this is the report from this observation. Now, to be fair, at this, in 1959 summer, I wasn't all that swift, so I wasn't out looking for this thing. Angelo A. Bernasconi of Saronno, Italy, observed the occultation of Regulus by Venus with a 2.4-inch refractor, that's 60 millimeters over in Europe, 60 power. With the aid of a stopwatch and radio time signals, the disappearance of the star was recorded at 1421 UT. Regulus became clearly visible at 1431. All right, that's a 10-minute event, more or less. 14 UT, subtract 5 hours to get Eastern Standard. And what do you got? 921. All right, and it didn't work for the Western Hemisphere. And apparently, this thing was a bear to observe. Because I've gone through God knows what, the general indices of volumes of Sky and Telescope, and we've got nothing. In fact, this was could have been a wonderful opportunity to learn about the atmosphere of Venus with a really bright star like Regulus. Because strip chart recorders were in full use and had been, I don't know, in 1959, probably at that point, it could have been 50 years. And good photometers were available, tube transistor units. What an opportunity to study the atmosphere of Venus with such a bright star. And apparently, it was very difficult or impossible to observe everywhere. And this is an aside. American Astronomers Report from April 1960. This is an aside, all right? Strike up the band. The Venus Greenhouse. Da-da-da-da. At Yerkes Observatory. It's a short digest of their papers given before the AAS in 1960. At Yerkes Observatory, Carl Sagan has computed the properties of the Venus atmosphere on the basis of 600-degree surface temperature. So, our God was hard at work as a young astronomer at Yerkes in the late 50s, and he presented a paper. The Yerkes astronomer pointed out that the Earth would have developed an atmosphere resembling that of Venus had it been placed in that planet's orbit very early in its evolutionary history. So, the occultation of Venus in 1959 came to nothing. I again, for the last time, will point out the great lost opportunity here. It is a real shame. However, there are also teensy-weensy planets that are called stars too. Little ones, little ones. And nowadays, the Book of All Knowledge, to wit, the Observer's Handbook, in every annual issue has this formidable list of minor planet stroke asteroid occultations of various stars and, well, everything. All in a digest. That how many times have I sat at the Lowell Myers during cheap coffee and stale donut time for $1, right? Sitting in that awful dining area in Lowell and looking at what's coming up and knowing I probably will fail miserably in attacking these things. But what I bring your attention to is this. 163 Aragoni, discovered in the 1870s. That's asteroid number 163, the 163rd asteroid discovered in the 1870s. And I don't know, I'm asking, in the mid-1870s, late 1870s, were photographic methods yet introduced for asteroids?
I believe so. What was the guy's name? Oh, it's in my asteroid lecture. I could look it up on my laptop.
No. I would rather sit here and speculate all night rather than have you get any real data.
E. Barnard, maybe?
I don't know.
Or is that too early?
I think it's too early for Barnard.
I think the guy's got 4-character last name.
So, he discovered Aragoni, and this was the big time. This was 1959 all over again. Instead of a big planet, both in reality and in angular diameter in the sky, it's an eensy-weensy planet. And the zone of the occultation, working from memory, was from northern Ontario right through east of Toronto, right over New York City, out and skirting very near the Bahamas. So we have a severe path from north-northwest to south-southeast. 20th of March 2014, 10 hours UT, more or less, was the event, more or less. So subtract 5 hours, you get 5 Eastern Standard Time. Well, what happened? That beautiful rendition by Buddy Holliday.
Photographic plates, 1850s.
For asteroids? Really? Hell, I mean, the first picture of the moon wasn't that much before that. 1850s are using, I understand you, photographic search for asteroids.
Yep.
1850s.
Henry Joseph Perrotin,
Yeah, Perrotin, that's right. I know he's in France.
1876.
Yeah, I know that, but I didn't, well, I don't know. We're not going to get into this now, all right? But who was doing this in the 1850s?
Looking it up.
There were a lot of them.
Maybe you could leave the room and do this.
There were a lot
And
of
I hope you're not going to send me a bill.
Make the noise of shuffling
James
the
Craig
papers.
Watson
What?
was discovering asteroids in Ann Arbor, Michigan during that time.
In the mid-19th century.
Tubby
Yes.
Watson, yeah.
Okay.
A lot of use of it.
All right. Okay. Fine. Muy bien. Moving right along.
You do know that the rings of Uranus were actually discovered during an occultation in 1977.
Yeah, I know. Yeah, I know. This was a marvelous opportunity to study Regulus, the diameter of the Regulus, The occulting body, 12.4 magnitude. The duration, this is a long event. Long event. I suppose because of the oblique path, this slashing path. 14 seconds. My God, I mean, you take a nap during that. And, of course, the Alpha Leonis, Regulus itself, is, what is it? Something like the 10th brightest star, 12th, I don't know where, something, you know, it's damn bright. So,
Regulus is down around 20.
20.
Not really that bright. It's about the 20th.
It is all in the Book of All Knowledge, but I don't want to take time to look it up.
It's
Right. I could say,
It's
Siri, tell me how bright Regulus is. While you're at it, could you give me a little toe sucking? All right, anyway. What happened?
Don't ever change, Gary.
So if we had the Great American Eclipse last year, or this, last year, shouldn't this be the Great American Occultation if it's striped right across?
I would say the Great North
American
American Occultation on behalf of the Governor General.
Okay.
Thank you. Yeah, that's right. This was going to be great. Oh man, I was abusing the coffee refill policy at the Myers, reading about this, just dreaming, right? All right. This is from IOTA. Volunteer observers invited to time the March 20th, 2014 occultation of Regulus. Your help is requested to observe and time a rare and beautiful astronomical event! All right. Update, 21 March. Weather across New York State appears to have foiled all attempts to observe the occultation in or near the path, with the possible exception of an observing team that went to Bermuda on Wednesday. This is from their website. Talk about bad luck. A whole week of beautiful clear skies, but then one cloudy night at just the wrong time. Oh well. That's scientific nomenclature. Oh well. Doing real science is like that. Yes, I had it figured out, right? Right. Do your best and take what comes. IOTA is grateful for every one of you for your efforts. We hope you will participate in upcoming events in which the star might not be quite as bright as Regulus, but still easy to see in a small telescope. That point is well made. Parentheses. If with my 50 millimeter, that's what I was going to use, my 50 millimeter refractor on a stinking camera tripod with the Bob Watt Memorial Eyepiece, right? 30 power. If you can't use that telescope in Roseville or Purgatorio, Farmington Hills to observe occultations, hang it up. That little telescope is perfectly capable of observing the brighter stars. And that's what I was going to deploy on this thing. The weather everywhere was horrendous. I mean, it was everything. It was rain, it was snow, it was rain mixed with snow. And I'm talking about the entire eastern quadrant, northeastern quadrant of North America. In fact, I remember talking to my brother a few days later. He knows his stuff. He built a 2.4 inch, he bought a 4.25 inch during the second Eisenhower administration, as did I. Only mine was bigger because I'm his big brother. I said, you know, back in the old Larry Kalinowski and Jack Szymanski days, it would have been like the old times. We'd have looked at a surface weather map. We'd have looked at, Environment Canada. The prospects would have been horrible. But that wouldn't have stopped us, because we'd have said, this is an occultation of Regulus, damn it. Let's go. Even with the rain coming down, we'd have been out on the 402. And then wound up somewhere far east of Metro Toronto at a Tim Hortons by an expressway interchange with the rain coming down in the parking lot, wondering why in hell we bothered living this long. But we would have done it because most of you have chased an eclipse and you think, oh, I know it's raining, it's horrible, it's sleet, but maybe the clouds will thin out, it's bright, you know, or maybe there'll be a hole, we could chase the hole, right? Yeah, well, and then there was one. So Jack and Larry couldn't go. I didn't go either. The only good thing to come out of this event was the great David W. Dunham, the grand old man of North American occultation observations. He went to Bermuda. There was a team that went to Bermuda. And if memory serves, there are zones of probability. There's very good chance, there's okay chance, there's so-so chance. He was 2 kilometers inside the so-so zone. Bermuda. I don't know the geography of Bermuda. He saw nothing. There was no event. He was the only one, or his team, I don't know whether he individually or he was with a team, they were the only ones who had got anywhere near a crack at this thing, and there was no event. I do not know. I suppose one could get on the IOTA website. Don't know when we will ever get a chance like this again. But in the literature, there was great enthusiasm because Regulus is obloid. I mean, it's not round like our sun. Dead nuts round. No, no. It's obloid. It's oblate. That's the term? Oblate. Yeah, right. And there was some great interest in doing digital observations. Digital. As opposed to what we'd have had at the truck stop, right, by the 401, right, out east of Toronto, right? Click, 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 click. Oh, I love that sound. Oh yeah. It takes me back. Right. I love it. Analog. Look at metal, glass. See? Right? That was the story of the great lost chance. In a way, it was the mirror image, the upside down, the inversion of our wonderful eclipse last summer, where, yeah, there were trouble spots, fine, all right, there were. But by and large, from one end of this country to the other, the weather was fairly good, and millions saw it. as opposed to this fiasco. So, in conclusion, comrades, the moral of the story is, A, insofar as you have to be told, amateur astronomers can lead the charge in this kind of event, and they can be great support service in the reduction of observations and in predictions. But it takes blokes like us to drive out in a rainstorm on the 402 on the hope that the sky will thin out or go anywhere in the middle of the night in March. The wider lesson is that people of modest education, training, modest instruments can get out there and get data. It's fun, and if you're careful, and if you know what you're doing, or you know how to ask the questions and ask the questions, you can do a good job. And it doesn't take a lot of gear. As I said, maybe a little sarcastically, if you can't observe occultations with a small refractor from your backyard in Roseville, you're just not that interested. Of course, you can say to me, how many observations of occultations have you ever made from a backyard in Roseville? And the answer is 0. I don't live in Roseville. But, see, I'm one of the big kids. I used to use the Veen Observatory in the old days, right? But that's another story. We can have a lot of fun and face and overcome, or on the other hand, be done in by some challenges. But this is the sort of thing that amateur astronomers are made for. That I have a great admiration for amateur scientists, even in this 21st century with big science and particle accelerators and space telescopes and all of this. If you are willing to go to the high Andes with a plankton net, you can discover things. It may not be too much fun, but you can discover things. Or if you're willing to go and observe these kind of events with your humble little telescope and a stopwatch, I point out that if I had been the only one to observe this thing on Bermuda with my little refractor in my stopwatch, with all due respects to the great David W. Dunham, I'd have had a leg up on all of them. All it takes is your willingness to get out there and do these things. It's like any other form of astronomical observation. It can be done. It's all there. And you've got the equipment. And if you don't have the equipment, you can easily lay your hands on it. And so now we have retrogressed, or we have disintegrated from science to essentially religion, right? Believe, brother, believe. And I thank you.
We got some time for questions.
Yeah.
Mr. Ross, the event in 1959 where Venus occulted Saturn?
No. 1962 was where Saturn occulted a star. In 1959,
Just didn't need it.
Venus occulted Regulus.
Okay, Regulus.
Yeah.
And that was the event that, there was only one recording that you can find.
That I can find. Maybe something's in a scientific journal. I don't know.
2048 is the next time.
Maybe the weather was bad at
2044.
that time.
Well, wait. Let him make his point.
Maybe the weather was bad at that time and not too many people were able to see that event. Because it would seem to me that would be a big event. Because here you've got two bright objects, easy to see in any size telescope, and you only have one recording of it.
All right, what, in 1959 or 60, what would be Sky and Telescope's source of information? It'd have to be correspondence or maybe perusing, you know, they're not so far from Harvard College Observatory. I don't know. I am not accusing Scientific American. I'm not accusing Sky and Telescope of indifferent reporting. It's just that it seems to me nobody contacted them, and maybe the weather was bad.
But back then, was Sky and Telescope the source of data entry?
No,
No. Oh no.
U.S. Observatory.
That would have been. That would be Her Majesty's Nautical Almanac Office, for instance.
So
Or the Japanese.
No, it could have been,
Or the U.S. Naval Observatory.
U.S. Naval Observatory or.
so a lot of different.
Palomar.
But it's just baffling that nobody recorded that event, like you
Well,
said.
this one Italian did with a 60mm refractor, and he got pretty good data because he was timing to the second here. I mean, the fraction of a second. Or was it second? Give me a second, just a
That
minute.
means we're on.
He
Hubble
timed
was
it to this. He timed it to the second. He was using a stopwatch and time signals from I don't know where.
Hubble was right.
But maybe there were reports in, I don't know, the Journal of the BAA, or in Astronomical Journal, or the Astronomical Society of the Pacific. I am unwilling to do, to excavate.
Why don't you try Google?
He's opposed to that, but we could all do it.
Well, I am the kind of fellow who will hire a Hindu to turn my light switch on in my synagogue, right, on Saturday. You do it.
And with that, we're done.
Yes.
Maybe permanently.
Insofar as you had a point, Burton.
Go to your room.
Well,
All right, at 2044, there's going to be Venus will occult Regulus again.
All right, so mark your calendars.
Yeah.
Start getting prepared.
And this is a picture of Regulus compared to the sun.
Is that due to spin, high spin?
Yes.
How bad?
Gary, I have,
That's Regulus compared to the sun.
Second of July.
So after the meeting, some of us go to the Coney Island on Van Dyke.
And I'll give you the time.
We're pretty much done here.
Very nice.
Have a good night, everyone. Stay warm.